I've had the privilege of studying high-performing technology organizations since 1999. That was a journey that started back when I was the CTO and technical founder of a company called Tripwire in the information security space, where I served for 13 years. We studied these organizations that had the best project due date performance in development. They had the best operational stability and reliability in ops, and they also had the best posture security and compliance. And so our goal was always to understand how did these amazing organizations make their good to great transformation so that we could better understand how other organizations could replicate their amazing outcomes. And so as you can imagine, in a journey like that spanned 20 years, there are many surprises. But by far for me, the biggest surprise was how it took me into the middle of the DevOps movement, which I think is urgent and important. The last time that I believe any industry is being disrupted to the extent that our industry is being disrupted today was likely manufacturing, when it was revolutionized through the application of the lean principles. And I think that's exactly what DevOps is. You take those same lean principles, apply them to the technology value stream that we work in every day, and you end up with these emergent patterns that allow organizations to do hundreds, thousands, or even hundreds of thousands of deployments while preserving world-class reliability, security, and stability. And I think that is what enables us to work with technology in a way that we just weren't able to do before. So 1 second, let me just confirm that the right microphone is being used. Yes, okay, great. All right, so before I begin, let me just share with you my definition of DevOps. So this is what we used in the DevOps handbook in 2016. It is the architectural practices, technical practices, and cultural norms that enable us to increase our ability to deliver applications and services quickly and safely. And that's what allows us to rapidly experiment and innovate, as well as provide the fastest delivery of value to our customers while ensuring world-class security, reliability, and stability. And so why do we care about that? It's so that we can win in the marketplace. And so I love that definition because it doesn't actually say what DevOps is. It just says, here are the outcomes that we aspire to. But as much as I like that definition, there's a definition that I like even more, and that comes from another London person, and his name is John Smart. For many years, he led the better ways of working at Barclays. And his definition is simply this: it is better value, sooner, safer, and happier. I love that definition because it's shorter, but I also think it is entirely accurate. So, I think there are many problems that still remain. So we wrote the DevOps handbook in, 1 second here. The DevOps handbook in 2016. The Phoenix project came out in 2013. And we wrote the Accelerate book in 2017, which was based on a cross-population study that spanned over 30,000 respondents, trying to understand what do high performers look like and what are the behaviors that predict performance. And yet, there's problems that still remain. And this is what I wanted to explore in the book, The Unicorn Project. One was the absence of understanding of all the invisible structures that are needed to enable developer productivity. Two is there's this other problem that still remains. So the DevOps community famously identified that it took so much effort to get code to where it needed to go, which is in production, so that it could create value for our customers. This other orthogonal problem is that around data, which is often is stuck in systems of records where it's too expensive to take all the data out. It's trapped in data warehouses, and it takes weeks, months, or even quarters to get it to where it needs to go, which is in the hands of developers so they can use it in their daily work. There's often strong opposition to support new ways of working, and there's ambiguity in terms of what behaviors are needed from our leaders to support this kind of transformation. And so these are the problems I want to explore in the Unicorn Project. And so in the Phoenix Project, we had the 3 ways, we had the 4 types of work. In the Unicorn Project, I'm using the concept of the 5 ideals. And so they are locality and simplicity. The second is focus, flow, and joy. The 4th is improvement of daily work. The 4th is psychological safety. And the 5th is customer focus. So in this presentation, I'll go through each one of them and give you an example of things that I think look like ideal and things that are not ideal. So before I do that, I just want to take a moment to describe some of the key findings from the State of DevOps report, just because it is so decisive that high performers exist and they are massively outperforming their not high performing peers. So we know from the 2019 State of DevOps report that high performers still deploy far more frequently. They're doing multiple deployments per day, which is 2 orders of magnitude more frequently than the non-high performing peers. When they do a deployment, they can do it in 1 hour or less. So that is, how quickly can they go from code committed into version control, through integration, through testing, through deployment, so that customers are actually getting value. So high performers can do it in 1 hour or less, whereas lower performers might require weeks or months, or maybe even quarters, and that's 2 order of magnitude difference. When high performers deploy, they are 7 times more likely to succeed without it causing a Sev1 incident, a service impairment, a security breach, or a compliance failure. And when bad things happen, which Murphy's Law guarantees, they can fix it far faster. In other words, the mean time to restore service for high performers is 1 hour or less, whereas lower performers might require up to a day or worse. And that's 3 orders of magnitude difference. And so 6 years in a row, it's been very decisive. High performers massively outperform non-high performing peers. We know over the years that there are other dimensions of performance. We know that high performers, because they're integrating information security objectives into everyone's daily work, they spend only 1/2 the amount of time remediating security issues. And there are other dimensions of performance as well. 4 years ago, we looked at organizational performance. What we found was that high performers, not only did they have better IT performance or software delivery performance, they were also twice as likely to exceed profitability, market share, and productivity goals. And we know that high performers, they're twice as likely to recommend their organizations as a great place to work to their friends and colleagues, as measured by the Employee Net Promoter Score. So this is all about engagement and all about happiness in our work. So to me, beyond numbers, this starts to suggest what the opposite of technical debt is. It is, to what extent can we safely, quickly, reliably, securely, and happily achieve all the goals, dreams, and aspirations of the organizations that we serve. And so in the Unicorn Project, that is, I try to verbalize this through the 5 ideals. So ideal number 1 is all about locality and simplicity. So in the Phoenix project, there was a lot of, it was all framed around like how difficult was it to create value for customers. I think one of the best examples of this for me was learning about the birth and death of a technology called Sprouter at Etsy. So it's all about how engineers work together to create value for customers. So in the battle days of Etsy in 2008, in order for customers to get value, 2 teams would have to work together. It would be the devs working on the front end inside of PHP, and it would also be involve the DBAs working on the back end inside of the Postgres stored procedures. And so even in the battle days of Etsy, they knew that this was a problem, because that these 2 teams would have to communicate and coordinate and synchronize and prioritize and schedule together. And so the goal was to try to explore how to get these teams to work more independently. And so that led to the creation of a technology called Sprouter. And that was short for Stored Procedure Router. And so the goal was to have the devs and DBAs work independently and then meet in the middle inside of Sprouter. And this, as said by Ian Malpass, one of the senior engineers there, said, this required a degree of synchronization and coordination that was rarely achieved, to the point where almost every deployment became a mini outage. And so if you're doing 30, 40 deployments per day, this is a real problem. And so as part of their rebirth of the engineering culture and engineering greatness at Etsy, their goal was to kill Sprouter. And what they found was that in every place where they eliminated Sprouter, and so Sprouter used object relational models to basically fully enable front-end engineers to make all the required changes without having to communicate and coordinate with anybody else. And that what they found was in every part of the property where they eliminated Sprouter, suddenly code deployment lead times went way down and the quality of outcomes went way up. And what's so amazing about this is that, in my mind, this is one of the best examples of Conway's Law. And so as we went from 2 teams having to communicate, coordinate, synchronize, prioritize to 3 teams, code deployment lead times went up and quality of the deployment outcomes went down. It was going from 3 teams to 1 team with no need to communicate and coordinate with anybody. Code deployment lead times went down, and the quality of the outcomes went up. And so for me, the big lesson here is that it's not enough to just move boxes around on an org chart. We must also have an software architecture that enables this type of work, that software architecture that is congruent to the org chart and the ways that we want people to work. And so what's so remarkable about the story to me is that look at the difference as we go from 2 teams to 3 teams to 1 team, and the difference in the outcomes. But in most large complex organizations, it's not just 3 teams having to communicate, coordinate, synchronize, marshal. It's often scores of teams. And the way we measure that is when you open up a ticket to initiate a deployment on the left, how many teams must work together before a customer sees value? And it's often scores of teams. We need environments. They need to be configured properly. We need test data. We need testing to be executed, regression testing, security approval, change approval, middleware teams. And it doesn't take much to go wrong before we are looking at software deployment lead times measured in weeks, months, or even quarters. And so one of the biggest and most delightful findings for me in the State of DevOps report was this. It is that architecture is one of the top predictors of performance. And by the way, if I didn't introduce the State of DevOps report, this is the work that I did with Dr. Nicole Forsgren and Jez Humble, where over 6 years, we've been able to study 36,000 respondents to understand what behaviors link to performance. And indeed, it is architecture that is one of the top predictors. As measured by what? It is to what extent can we make large-scale changes to our parts of the system without permission from anyone outside the team? To what extent can we complete our work without a lot of fine-grained communication and coordination with people outside the team? To what extent can we deploy and release our service or product on demand, independent of services that we may be reliant upon? To what extent can we do testing on demand without the use of a scarce integrated test environment, of which there are never enough? They're never cleaned up enough, and which actually jeopardizes the testing objectives. And if all those things are true, then we should be able to do deployments during normal business hours and negligible downtime. And so this shows that it is architecture that impacts more than anything else how daily work is performed, especially for developers. And so in the Phoenix project, a measure that we explored was the bus factor. In other words, how many people need to be hit by a bus for our service, our project, or our organization to be in grave jeopardy. And in the Phoenix project, the bus factor was 1. It was Brent. No outage could be fixed without Brent, nor could any major piece of work be done without Brent. And so we want a bus factor, not just 1. We want it to be larger than that, to the size of a team, or maybe even the team of teams. In the Unicorn project, the metric we explored is the lunch factor. In other words, how many people do we need to take out to lunch in order to get what we want done? And so is it the Amazon ideal of the 2-pizza team? Or do we need to feed everybody in the building? And so if, for example, in a complex deployment that involves 100 or 200 people, we do have to feed everyone in the building. So ideally, we want that lunch factor to be far smaller than that. So the ideal is that when we need to implement a feature, we can implement it just by looking at one file, one module, one namespace, one application, one container, what have you, and deliver value to the customer just there. Not ideal is to implement our needed changes. We need to understand and change all the files, all the modules, all the applications. And so that is clearly not ideal and drives the lunch factor way up. So another aspect of the first ideal is that we can make our changes independently from everyone else and test them in isolation from everybody else. And so that's the notion of composability. Not ideal is that in order for us to test our changes and get any sort of assurance that will actually work in production, we must test the entire system, that every other component must be present. And that's what drives the need for these scarce integrated test environments. So it's not just about the code and our ability to test. It's also to what degree we have, every team has the expertise, capability, and authority to do what the customer asks us to do. So that's ideal, that's embedded within team. Not ideal is to actually do what the customer wants. We have to escalate 2 levels up, over 2, and then down 2. So a visual depiction of this is that in order for any decision to be made, we have to go up 2, over 2, and then down 2. And so a friend of mine said, yes, that's exactly what happens, but we consider ourselves lucky if we don't have to do the return path. In other words, we actually have to go up to, over to, and down to, and then back again in order for two engineers to actually work together to solve a problem together. So in my mind, one of the best examples of this in a non-technology environment is the book Team of Teams by General Stanley McChrystal. This is an amazing story about the Joint Special Forces Task Force in Iraq in 2004, where they were battling a far smaller but far nimbler adversary. And this was just actually one of the two most amazing books that I've read in the last decade that I'll mention in this talk. And this required pushing decision-making all the way down to the edges. One of the lines in the book that I thought was so remarkable was the notion of the team. So he said that because the Joint Special Forces Task Force was made up of the special forces across every military branch, the team was the boundary of which everyone else sucked. Right, so if you are in the Army Rangers in the U.S. Army, having to deal with the Navy SEALs in the U.S. Navy, the team was the boundary that everyone else sucked. So the only way that they could actually achieve the mission was to actually create a team of teams that could actually work together to achieve a common mission. In this case, it was to protect the safety of the citizenry that they were tasked to protect. And so I think there are so many lessons in this book that are relevant to the work that we do every day. So one last element of the first ideal is around data, that in the ideal, every team has access to the data they need on demand, quickly, accurately, and securely. Not ideals that in order for people to get the data they need, we have to wait months, weeks, or even quarters, and just hope that when we change the schemas, every report won't break like last time. And just to paint the magnitude of this problem, my friend Chris Berg made the observation that somewhere between 35 to 50% of most organizations, 35 to 50% of employees in most organizations access or manipulate data as part of their daily work. So that as a population is actually significantly larger than the population of software developers, of which we are a part of. So this is a problem that we need to solve. So ideal number one was about locality and simplicity. The second ideal is about focus, flow, and joy. And that is really the outcomes when we can actually achieve the first ideal. And so much of this was informed for me by learning a functional programming language 4 years ago called Clojure. So it's a functional programming language that runs on the JVM or transpiles into JavaScript. And for this language really reintroduced the joy of coding back into my life. And just to put this in the context, for almost 2.5 decades, I've self-identified as an ops person. And this is despite having gotten my graduate degree in compiler design and high-speed networking in 1995. And I think it was because that it was my observation that it was ops where the saves were made. So it was ops who saved the customer from terrible developers who didn't do enough testing and blew everything up when they deployed into production. It was actually ops that protected our data and our code because of ineffective security people. And yet, I've changed my mind. 3 years ago, I now decisively self-identify as a developer. And I think it's because that you can do so much with so little these days, and the work can be so fun. And one of my favorite quotes comes from the French philosopher Claude Lévi-Strauss, and he would say of certain tools, is it a good tool to think with? And I think there's so much about functional programming, such as immutability or composability, that are better tools to think with. And so functional programming was pioneered by Lisp and ML. It was popularized by many other programming languages, including Clojure. But what I find so exciting is that functional programming, these concepts are going far beyond just programming languages. And I think it is a great thing that it is showing up in so much of infrastructure and operations as well. Docker is fundamentally immutable. If you want to make a lasting change, you can't make it inside the container. You actually have to make a new one. Kubernetes shows that same concept, but in the larger scale of the system of systems. Event streams, whenever you see something like Apache Kafka, chances are that it reveals this desire for an immutable data model where you can't rewrite the past. Instead, it is an immutable log of what has happened. Interestingly, version control, especially Git, uses an immutable data model, which is why you get yelled at if you rewrite the commit history. So the second ideal is all about focus and flow. The ideal is that your time and energy is focused on solving the business problem, and you're having fun. And for me, the not ideal is that all your time is spent trying to solve problems that you don't even want to solve. For example, trying to get the YAML files to parse correctly, or trying to figure out how to escape spaces and file names instead of make files. And so what Clojure has done to me is that there are so many things I used to enjoy in my past that I don't enjoy anymore. In fact, here are a list of things, not exhaustive, just merely a sampling of things that I detest now that I used to love to do. It is everything outside of my application. It's connecting anything to anything else, including databases, because it always takes me at least a week. Updating dependencies, secrets management. In fact, I'm the person who usually checks in secrets into the repo, which causes all sorts of problems. Bash, YAML, patching, building Kubernetes deployment files. I'm the person who can't figure out why my cloud costs are so high. And so this is not to diminish the importance of any of these things. Instead, these things are as important as the features we build. It just is because that I just don't get much joy in doing them anymore, because building our feature is just so much fun. And I think this really shows how important infrastructure is, and that more and more our expertise in infrastructure and operations and security is being embedded into our platform, so that any developer who uses it can benefit from it and be able to safely, securely, reliably, and securely do our work. And we can do it on demand, self-service, without having to open up a ticket. We can do it with immediacy and fast feedback, which allows us to have focus and flow and even joy. And it's so exciting to me that so much of our work can be done this way, whether it's monitoring, deployment, environment creation, security scans, orchestration. And all these things is why I believe that the best days of infrastructure and operations and security are not behind us, but they are ahead of us, because our expertise doesn't belong in our heads. Instead, it belongs in the platforms that we build that enable other fellow engineers to do their work securely and safely. To motivate the notion of flow and happiness, I'll point you to this amazing talk. It was probably one of the best TED Talks of all time, in my opinion. It was given by Dr. Mihaly Csikszentmihalyi. His talk was called Flow, The Secret to Happiness. He wrote a great book called Flow, The Psychology of Optimal Experience. And he describes the state of flow as being when we're so engrossed in our work, we're having so much fun that we lose track of time. We might even lose sense of self. And I think that is what attracts so much of us to technologies, that, and I associate that with coding, when you're having so much fun solving a problem that we lose even sense of self. And so the two types of learning he talks about is, one, the first type is procedural learning, or maybe even sometimes called declarative learning. And that's the learning we value, because it often builds on learnings from previous decades, and everything that we acquire, we will probably use for decades to come. And so this is the type of learning that we enjoy. On the other extreme, we have one-shot learning. And so what one-shot learning is, it's the problems that we need to solve, not because we want to, but because we need to. In other words, these are problems that we Google for or Stack Overflow for. In my case, it might be, in this case, trying to figure out how to parse Java time instance. It's not something I woke up in the morning and decided to do. Instead, it was something that I just tried, that I stumbled into and had to do. So I keep a screenshot of Google searches that fall into the category of one-shot learning. My goal is to do as little of that as possible. So the ideal is when we can implement and test our features, and we can do it on our laptops and learn whether it will work within seconds. Not ideal is that the only way that we can determine whether what we built works is by waiting minutes, hours, days, or maybe even weeks. Ideal is trunk-based development, that we are working in maybe feature branches, but we are checking back into trunk frequently, ideally multiple times a day, and whatever's being checked into trunk will get moved into production, or at least into a production-like environment. Not ideal is that every time we need to merge code from different development teams, we spend 5 days merging, and we have 50 people trapped in conference rooms. And on this next slide, it's just a screenshot. Often I'm working on projects by myself across multiple feature branches. And what I found is that I can't even merge with myself. And what this is, in fact, often it's easier for me to retype the changes than to actually use an automated merge. And what this has shown me is that our ability to merge across hundreds of developers when we do it infrequently is at best an illusion. So ideal number 1 is locality and simplicity. Ideal number 2 is focus, flow, and joy. Ideal number 3 is improvement of daily work. So this showed up in the Phoenix project, and this is predicated on the statement that improvement of daily work is even more important than daily work itself. So not ideal is TWADI, the way we've always done it. Ideal is MTBTT. Make tomorrow better than today. And so that's principle number 2 in the Google SRE. And so an example of not ideal is in manufacturing. In the General Motors Fremont plant in Northern California, this plant is notorious because it was for decades one of the worst performing automotive plants, not just in North America, but around the globe. This was before it being the site of the joint venture with Toyota as part of the NUMMI joint venture, and then later it became a Tesla manufacturing plant. But in this period, there were so many studies where it was shown that there were no effective procedures in place to detect problems during the assembly process, nor were there explicit procedures on what to do when problems were found. As a result, there were instances of engines being put in backwards, cars missing steering wheels or tires, and cars even having to be towed off the assembly line because they wouldn't start. And so that is obviously not ideal. What does ideal look like? Ideal is when we are putting into our system as much feedback as possible in as many areas as possible, sooner, faster, and cheaper, with as much clarity between cause and effect. Because the more assumptions we can validate, the more we learn and improve our ability to fix problems and innovate. One of the central themes in dynamic learning organizations is this notion that in order for us to win in the marketplace, this requires us to outlearn the competition. And so one of the most studied organizations in dynamic learning organizations is Toyota. And one of the most visible tools for this is the Toyota Andon cord. And I had the privilege in 2011 of going to the University of Michigan for a week and getting trained in the Toyota production process. And it was so amazing to me to find in the plant tour portions that on top of every work center modeled after the Toyota production system is this cord that everyone is trained to pull when something goes wrong. If I create a defective part, I pull a cord. If I get a defective part from someone else, I pull the cord. If I have nothing to work on, I pull the cord. And even if the work takes longer than documented. And so everybody knows now what happens when you pull the cord. It's that if the assembly line, if it can't be resolved within 55 seconds, the assembly line stops. So I knew that going into the training, but what I didn't know was how many times in a typical plant, in a typical Toyota plant, the Andon cord is pulled. So just in your head, just think order of magnitude, how many Andon cord pulls are there in a typical day? And the answer is this, 3,500 times per day. And so what I find so astonishing about that is that it's so disruptive. The way I was trained as a first-line manager was that I was supposed to solve my problems in my area of control before it caused a global disruption. And it seems like the Toyota production process is doing the exact opposite. We're magnifying disturbances so that local problems become global disturbances. And when you ask why do they do this, they'll say that if we don't put in a systemic fix then and there, we're going to have the same problems 55 seconds later. And so that's the notion of a daily workaround. And so daily workarounds exist in our work as well, but because our work takes longer than 55 seconds, it is not as visible, but it is just as destructive. And so that is a notion in our world of technical debt. And so greatness is never free. We have to create greatness. And so I'm going to tell you the story of technical debt using only up and down arrows. Someone wise once said to me 15 years ago, when dealing with executives, stick with only small numbers and primary colors. What I found in my journey is that that is not sufficient. At a certain level of seniority, you must stick with something even simpler. In this case, it is up and down. So think back to when you were in a situation where you had to get to market, and it was all about getting features to market, either to be first in market or just to get into the market. And so when we do that, we focus on getting features in. And often we'll take corners and deliberately take on technical debt. And when we do that, often we reduce quality, and that drives up the number of defects. But the story doesn't end there. As we look further in time, we find that the number of features goes down and the number of defects go up to the point where we can even exceed 100%. And this is when defects fixing dominates daily work, site reliability tanks, we go slower and slower, customers leave, morale plunges, and everyone leaves because everything is just so hard. And so John Cutler tweeted me years ago. He said, yes, that's exactly it. In 2015, a certain reference feature would take 15 to 30 days. 3 years later, the same class of feature takes 10 times longer. And who hasn't felt this? Is that what used to be easy is now hard. And this is despite hiring more and more developers. And so if you felt this, you are not crazy. It's because of technical debt. And so every tech giant has gone through this, and some have survived. And here's one example that didn't. It's Nokia. The second book I'll recommend in this talk is Transforming Nokia by Risto Salasma. Again, one of the best books I've read in the last decade. So Risto Salasma joined the board of Nokia. He was the founder of F-Secure and considered it to be the best job in the world. But then it was this unflinching look of how ineffective he was for many years because of an overly domineering chairman. Happened in 2010 when he learned from the VP of security at Nokia that the build times for the Symbian OS system took 48 hours. He said it felt like being hit in the head with a sledgehammer, because he knew that if it took 2 days for a developer to learn whether his or her change worked or would have to be redone, there was a fundamental and fatal flaw in the platforms that all near-term profitability and long-term viability hinged upon, which is why they rapidly switched from Symbian OS to Windows Mobile, which didn't work so great for them either, but it was actually a far better bet than staying on Symbian OS. And so Nokia didn't make it. However, here are all the organizations that managed to escape the technical debt trap. eBay, Microsoft after the Summer of Worms, Google that rose to the creation of the automated test culture, Amazon 2004 that led to the famous Jeff Bezos memo where all teams would work through APIs, Twitter, LinkedIn, Etsy. All of these organizations were able to defeat technical debt by reducing work on features temporarily. The most famous example of this was enshrined by the famous Trustworthy Computing memo from Bill Gates, then CEO. This was after the Summer of Worms, where SQL Slammer, Code Red, Nimda essentially created an existential risk for Microsoft. And Bill Gates wrote, if any developer has to choose between a feature or fixing a security issue, you always fix security. And so what are the decisions that each one of these organizations make? They say, we're going to take features down to 0, which allow us to pay down technical debt, which allows us to increase quality, which allows us to reduce down defects, not maybe to 0, but something that we can actually manage and on a daily basis, which allows us to re-platform and dramatically increase our feature throughput. And it's not just from CEOs, it's from product owners and UX as well. This is Marty Kagan. He wrote one of the most revered books in the product and UX community, Inspired, How to Create Products That Customers Love. And he said you must allocate 20% of all cycles to paying down technical debt. And he learned this after he spent 2 years as a VP of product management at eBay, where he didn't ship a major feature. And he said, if you don't pay your 20% tax, it is inevitable that you will pay 100% tax. And so you must allow engineers to work on problematic areas of code, refactor, re-architect, automate, so that we never get into a situation where we can't ship features. So in terms of enabling greatness, ideal is that we allocate 3 to 5% of our developers dedicated to improving dev productivity. Google famously has 1,500 developers working on dev productivity. It's over $1 billion of annual spend. Microsoft has likely over 2 to 3x that. Not ideal is the only person working on dev productivity or CI/CD pipelines are the summer interns or the people not good enough to be featured developers. In fact, at Google, Microsoft, Facebook, Amazon, they don't put their most junior developers on dev productivity. They put the most senior developers, ideally ones that have ops experience as well. So in this great example of karmic continuity, Satya Nadella, CEO of Microsoft now, he said in a town hall meeting earlier this year, if a developer ever has to choose between a feature or working on dev productivity, always choose dev productivity. And so they're playing the forever game. They're allowing compounding interest to work in their favor. So Google famously has 15,000 engineers running 5,500 code commits per day, 75 million test cases daily. That's not as good as what they became. 30,000 developers, 45,000 commits per day, 150 million test cases being run daily. So the best are always getting better. Not ideal. If someone breaks a build or needs a peer review, that person has to wait until someone frees up. Ideal is whenever someone needs a peer review, I drop whatever I'm working on because we know that the longer that person has to wait, the worse the outcomes. We know that the most important work of the day is fixing when you break the build or break the tests. And the most important work of the day is to get ourselves back into a safe, releasable state. So the first ideal is locality and simplicity. The second ideal is focus, flow, and joy. The third ideal is improvement of daily work. The fourth ideal is psychological safety. So in the State of DevOps report, the Westrom organizational typology model showed that culture is one of the top predictors of performance. We know in lower performers is highly correlated with information being hidden, messengers of bad news being shot, discouraging bridging between teams, and covering up failures, whereas the highest performers is correlated with messengers being trained to tell bad news, information actively being sought, responsibilities being shared, meaning uptime is not just ops' job, just like security is not just InfoSec's job, it is everybody's job. And so when failures happen, it causes a genuine sense of inquiry, and we welcome novelty. What was so fun in researching the Unicorn Project was to look back into another group that studied this cultural norm, and that was Google. They, through their Project Oxygen and Project Aristotle, they found that when they were asking what made great teams great, the top factor was always psychological safety. To what degree do people on the team feel safe to say what they really think without feeling insecure, embarrassed, castigated, or being blamed? And there was actually something more about Project Aristotle in the State of DevOps Report 2019. And so it is psychological safety that enable great practices like blameless postmortems and chaos monkeys. You certainly can't do things like this without it being safe to take down production and being thanked for it. One of my areas of passion for the last 6 years has been studying not so much the unicorns of the Facebook, Amazon, Netflix, Googles, but the horses, large complex organizations that have been around for decades or even centuries, and learning how DevOps principles and patterns are being used to elevate productivity to help their organizations win in the marketplace. And so we've had this conference for 6 years in the United States and going on the fourth year in London. And without a doubt, these large complex organizations are absolutely getting as much success from DevOps as the tech giants of Facebook, Amazon, Netflix, and Google. So first ideal, locality and simplicity. Second ideal, focus, flow, and joy. Third ideal is improvement of daily work. Fourth ideal is psychological safety. And the last ideal is customer focus. So one of the biggest aha moments I've had in the last 5 years is this. I went to visit CompuWare, the famously resurgent mainframe vendor based in Detroit, Michigan, with my friend Dr. McKirsten, CEO of TaskTop, and we learned so much from him, Chris O'Malley, the CEO there, that we decided to spend a day just hanging out with his team, understanding how it ticks. And when I was walking to their campus with Mick, I looked at the agenda they had put together, and I was immediately embarrassed because the first thing on the agenda was a data center tour. And I apologized to my friend Mick, saying I have no idea what I just signed us up for. I don't know what we're going to learn by looking at halon extinguishers. And yet, it was one of the biggest aha moments of my career, because what we saw in the data center was this. It was basically empty. There were 2 Z mainframes, but the rest of the data center were those empty spaces where the racks used to be. You can see the green outlines. They're like the outlines in a murder scene where the racks used to be, and inside of each outline is a tombstone of which used to run there. It's the name of the business process and the application, as well as how much they saved by getting rid of it. And what was so amazing, and you can even see the sign on the left that says over 18 tons of obsolete equipment removed and recycled. And I thought what was so amazing about this was that it was one of the best evidence and examples of core versus context. By doing this, by getting rid of everything in the data center, they were able to reallocate $8 million of cost and reallocate that into R&D. And so this core versus context comes from Dr. Geoffrey Moore. He wrote the famous Crossing the Chasm book, but the better book is Zone to Win. So he defined core as the core competencies of the organizations that create lasting, durable business advantage. And context is everything else. And so that data center picture was $8 million of context reallocated to core, that things that customers are willing to pay us for. So context is mission critical. It's our financial systems, it's payroll, but customers are not likely willing to pay us a premium to create world-class payroll systems. And why Dr. Geoffrey Moore cares about this is that in so many organizations, context starves core. And so not ideal is when functional silo managers prioritize silo goals over our top business goals. Ideal is that we're looking at what we do on a daily basis and ask, do customers value this? Do customers pay us for this? And if not, maybe we shouldn't be doing it at all. And it doesn't mean that our teams go away. Instead, we have to ensure that our teams have the skills to thrive in the long term. So I think this so much is important to every organization, especially those that have been around for decades and centuries. So why do I think this is important? This actually comes from this line. The world is changing very fast, but big will not beat small anymore. Instead, it is fast beating the slow. And so as much value that the tech giants have created, Facebook, Amazon, Netflix, Google, Microsoft, as much value as they've created, and that's trillions of dollars certainly, there's no doubt in my mind that the amount of value that will be created when every large complex organization adopts the same principles and patterns that the tech giants have and enable their developers to be as productive as if they were working at a Facebook, Amazon, Netflix, Google, that will create tens of trillions of dollars per year. And so when we can do that, suddenly all of these problems that look impossible to solve, it become very, very doable. And so that is why I think DevOps is so important. So the 5 ideals is what we use in the Unicorn Project to frame these concepts. And I'm so delighted that 2 weeks ago, the Unicorn Project actually hit number 2 on the business hardcover bestseller list. And so this is so important to me just because it means that a technology book is showing up alongside other books that business leaders lead, showing that this is not a problem that we can delegate to our technology people. This is something that must be owned by all levels of leadership. So if you are interested in getting excerpts of the Unicorn Project, as well as excerpts from any other book, as well as links to the videos of all the DevOps Enterprise Summit videos, just send an email to realgenekim@sendyourslides.com, subject line DevOps, and you will get an automated response with all these resources. With that, Tony, that concludes the prepared part of the presentation, and why don't we unmute and go to Q&A. Thank you so much for your time, and looking forward to Q&A.
Thanks, James.